So in this video we will talk about the Heisenberg Uncertainty Principle. So first we understand what is the principle and what will be told by the Heisenberg, and so let's begin. The Heisenberg Uncertainty says we can't the proper language I will give, but in understand language we say that the position and the momentum, that is velocity, means we can't calculate simultaneously the position and the velocity of nanoscopic particle. Means like electron, photon. Means if we have a nanoscopic particle, suppose it is a nanoscopic particle, okay, like electron, photon, or nano, the nano 100 times electrons, blah blah. So means Heisenberg says if we have a nanoscopic particle, microscopic particle, okay, so we can't able to find its position, and its position we said denoted by x, and its velocity or its momentum. Okay, basically velocity by momentum, because basically the mass into velocity, so we can calculate easily. So Heisenberg says if we have a nanoscopic particle like electron, proton and else, we can't calculate the both simultaneously in a nanoscopic particle. Okay, like if we suppose, for example, be mathematical. For example, suppose this is the arc where a nanoscopic particle, like suppose this is the electron which is moving in this arc. Okay, let's assume this is the root of the electron, and here suppose here to here is the root of an electron. So the electron is in its bike and moving their route. Okay, so supposing the electron is moving in a path, a photon of wavelength 1, okay, this is the photon of wavelength 1, collide with this electron. For example, this is the wavelength of photon 1, collide the electron. Because of the collision, the amount of the photon's wavelength is high energy, because of wavelength is low, less than 1. So it diverts the path. For example, where so moving here it collide, and the diverts is, for example, here and here, suppose they diverts their path. Okay, here if the photon collide here, suppose they diverts the path. Suppose in startingly we call the photon here collide the point A, so the diverts path of its original. Means the for example, the pacers throw the ball in baseball and divert the ball by hitting collision of bat and ball. So for example, here the photon collide, and so in this the photon energy and the photon velocity change. In this is the speed, for example, v, so the v dash now change, and the position now change. Okay, so here the Heisenberg says we can't find the velocity and the position simultaneously. Okay, means now the photon wavelength collide this, so in this we can't find the velocity, because we know here the velocity we know, but now I can't understand. But we position, yes, we know in this, and with photons wavelength is less than 1 and equal to 1. this angstrom, the wavelength of the photon are less than 1 and equal to 1 because of high energy. Here is the high energy, because wavelength angstrom 1 means the wavelength between them is very less. This is the wavelength, is very less, so that's why it has high energy, like a spring, the more compressed, more flex, so like a spring. So the wavelength is less than 1 angstrom. It has high energy. Due to high energy, the path and the position divert and the velocity divert. So we in velocity delta v, we can't understand, we can't find, but the position in x we find, because now we find the position of this. Okay, and now a second case, assume that same wavelength, okay, same, this is arc where the electron moving. Okay, now assume again a photon collide with electron, but now the angstrom wavelength is 1, means now the wavelength of photon like this is the greater one, so it has high low energy. So due to the low energy, now the after collision the electron not change their path, it follows their original path. So in this case, because of the its original, the wavelength is greater than 1. So in this case, the delta we easily find out, because the this has velocity as well as the starting, but we can't find their position, because in in arc we not find the position of the electron in this arc, in this path. So we can't find. So here the Heisenberg says that any nanoscopic particle like electron, proton, photon, anything else, we can't find the position and the momentum or velocity of the particle and simultaneously. Okay, this is the Heisenberg Uncertainty Principle, and the mathematical order of one thing, that it this for only microscopic, okay, yeah, nanoscopic. But if we have when the case are macroscopic particle, macroscopic particle, which is greater than, of course, is the greater than electron photon, like a football, okay, like a football, like a ball or cricket. This is the football and this is the cricket ball or the baseball, for example. So if, for example, a bowler in cricket, okay, your baseball, the thrower throw the ball, and after the collision of bowling, we easily find the position of macroscopic ball, momentum, velocity, and also position. So we easily find the position, momentum, or velocity. Sorry, position, momentum, velocity. We easily find. Okay, so here means the Heisenberg principle only applicable in the micro, not microscopic. This is the significance, means that if you have a cricket ball after collision, in not collision, if in the case of collision and anywhere with the throw, we easily find their position, we easily find the momentum simultaneously. We find the momentum, velocity, the delta x, which is the position, we easily find out. So here the are the Heisenberg Uncertainty Principle, and in next video we talk about their theory, what is the Heisenberg says in the principle, and in mathematical way we do some questions to understand the Heisenberg Uncertainty Principle and in proper way of writing the notes, which is okay. This is the example and the short form. Okay, so keep studying. We will meet in next video. Bye bye.